Hello everyone. Sorry. Hello everyone. My name is Godwin Orwell. So because of how um, the tension about machine learning and deep learning and the course of the MSCFE, I just want to show you how easy it is to understand this machine learning and stuff. So this is a full process of data science. Not full process though. This is what I was using when I started, with data science. This was one of my projects. So I want to share it with you to show you how easy it is. Sometimes it can get more complex than this, but this will, take that pressure out, ease the pressure a little. So all of this is just the code. This is my workstation though. So this is what I was saying, that you guys have to create to make sure that this code will run perfectly, because it's a lot of work, it's a lot of time. There are some things you have to download to make sure that the Python works fine and so on. But if you don't want to go through these long steps, you just use the Google Colab. But I have to teach you how to get the data into that part, because it's not the same way. It's not the same way you do it in your in your local system, just like this one. So this is the studio, and then I want whatever is here to replace itself here. Like whatever I run here, I want to be seeing the results in this place. So this is called a Jupyter notebook, but I want this to be more interactive, and and I think this is the only way you can separate this in VS Code. I really don't like using the what they call this. I don't like to use the terminal, yes, to run all of it at once. I don't think it's more explicit like that, and I don't think you can use the terminal to run all of this, because there's a lot of things. It's not like one code. It's not as if you're just doing machine learning alone. So you're trying to um, explore the data, you are trying to wrangle the data, you have to clean it, that's wrangling, then training, testing, and so on and so forth. So you can, from training and testing the data, you can, all of this you can run it one hand from using a terminal. But I don't think I want to show you the whole full, before time. And also you have to bring in the data too. So let's start. So this import you see here, they are all what are very necessary to run this program as of this stage. um there can be so many. It depends on what you are trying to use to run your model. But you see this um this this maybe, they are all very important. You may literally see it in all um, data science projects, even um, in finance. So I'm importing pandas. Pandas is a tool for data manipulation. It's a module for data manipulation. It's used to manipulate data. You want to clean the data, you want to um, rearrange the data, you want to structure it in a kind of way that it will be more pleasant. This is where you can also use pandas to plot. But I really don't use that often, because I feel the better way is, I will show you where I use pandas to plot here. But also you can use it for plotting. It's majorly for data manipulation. So this is me running my first code, which is importing pandas as PD. PD is what I want to import pandas as. So instead of me using pandas, I use PD. So this is it. That's the first one which has been run. So this is the second one, which is NumPy. NumPy is for numbers, to make sure you manipulate numbers properly, to make sure, especially I use it during featuring, that is feature engineering. So feature engineering means you're trying to arrange the data to make sure that the algorithm or the model you're trying to run it on understands the data properly. So this is matplotlib for charts, and graph, to make sure you see the data, what the data is, for you to understand the data properly. So this is Seaborn. This is like a subordinate of matplotlib. It's just to make the plot more presentable and interactive. And this is math. Well, I just put this here. It's not really, I don't think you'll be needing it here. You use math for more complicated aspect of data science, where you need cosine and sine and so on. I have a project like that, but let's just keep our head in this little one here. Okay, so I want you guys to understand this language. It's just a language. I want you to speak the way I'm going to be speaking, the way this codes are speaking to the machine. So I want you to understand as I am speaking that way. So please understand the way I communicate. Alright, so I want this data set that I want to import to be called SUV prediction. This. So I tell the machine, hey machine, I want this data to be called SUV prediction. So I said, machine, make this SUV prediction and then equal to, then I want to use this PD, which you see here, it's called pandas, for data manipulation. I want to use it to import this data because the machine will very much need the PD to import the data. So I write use, like equal to, let's say equal to means use PD to read CSV. Now the data I'm trying to bring in is a CSV file. There is Excel, there is HTML, that is if you are getting from the online or so, or yes, something like that. So there is more, depends, there's JSON, so it depends on where you are bringing the data from. So but mine is CSV, so I want this machine to read CSV file from this part which is on my local device, this part which is on my local device. So this is the data right here, .csv. So if you want to get this, you click on, when you download the file, I'm going to send it to the group when I post this video. So when you download the file, you right click on it. I don't know if it's this right click. Yes, if you right click on it and then you copy part, and then you paste it here. And do not use double quotes, use single quotes. That is for me. And do not forget to write this read. This R means read. So you read this part to bring in this data. So you click on execute. When you want to execute, you click on Shift Enter. Don't know if I've said it before. Now the next step, I want to see this data. I want to know what it is. So I said, okay, now that I have mentioned this, I want this data to be SUV prediction. I have made it SUV prediction. So I want this SUV prediction, I want you to show me the first 20 rows, the head, that's the head, like the first 20 rows of it. That's the, yeah. So head just, depicts first. So the first 20 rows of it, I want to see it. So I click enter, that's shift and enter, and then this is it. This is the first 10 rows. Then I go here and then I see the next 10 rows. That's just as simple as that. If I just want to see 10, I just click on it, and here it is. 1 2 3 4 5 6 7 8 9 10. In Python, 0 has a meaning. It has a count. So now that we have imported this data, we can do more. We can describe the data. Oh, sorry. We can describe this data. So I copy, Ctrl C, Ctrl V, describe. Now this shows nope. So this shows the count, that's the total amount of this the data set. This is, we have 400 of this data. Then we have the mean of this is the mean. We have for each of them, for each of the columns, there is a mean, there is a standard deviation, there is MIN, there is this is quartile range, percentile, and so on. This is the minimum, this is the maximum number in the data. Something, yeah. So I think something is wrong here. Oh, okay, this is because it's user ID. So this is actually what, this is the breakdown of what is on, in the data. This is you describing the data. So now, financial analysis. We want to analyze this data. Now, I do not think you will be needing this in the machine learning course, but you see this, you'll be needing them. But this is very, very sophisticated. It's very cumbersome. But this is just a little I want to use to show you how to plot the data. Sometimes you have to plot a lot of, you have to check times. It depends on how lengthy the data is, how many rows, if there is time, there's date, all of those count when you are trying to analyze the data. This is more of you can use this using Power BI, but for you not to waste your time trying to be switching softwares, you just do it one hand. That is in the code. So I will be running this one. So I want to explain this. So this is it. Now you remember I said Seaborn is more of a subordinate of Matplotlib. So it's like I want this Seaborn to be more I want the visualization to be more clean and more interactive. But this one line is not clean. It's not really the full. If you really want something to be very neat and very clean, there is a lot of codes you have to write. But this is a basic code that if people still see it, they will still be able to relate with what you are trying to do. So I'm trying to say this SNS, I want it to count and plot. Look at this count plot. I want you to count and plot the gender as X. In the in a chart you have the X-axis and this is the Y-axis. So I want them to plot this as X-axis in the data, this data called SUV prediction, which is this that I have named this file, which is this CSV file. Let's see what happens. Let's see what comes out. So we see the gender male and female, we see that females are slightly more than males. That is, females buys cars, buys SUV more than the male. So we are going to, this is pandas. This is now pandas, and I'm trying to show you how to plot using pandas. This is just a straight plot. So you just write again SUV prediction, that is this data. I want you to take age from this data and plot a histogram using that age in the data. You then control enter. This is the plot. So basically this data is made up of people at the age range of let's say 35 to 45. So that's the major representative in this data set. So it actually makes sense because, you know, we really rarely see people that are 20s in the you know, workspace, and 60s is retirement. Okay, so we are going to the next one, which is now we want to plot, we want to count plot using SNS. We want to count plot X gender with, we want to also paint this danger based on the purchases. So we want to know like how many male and female, you know, purchase and did not purchase. You know, this one is just for purchases. No, this is just for how many genders in the you know, in the data set. That's the genders, like their representation in the data set. So we want to know how many purchased SUVs and how many does not purchase, did not purchase it. So this is where we, you know, check that. So you see, males is almost equal, but again, a female won this one. They are almost equal. So we are going to the next one, which is data wrangling. Now, wrangling means cleaning. We just want to clean the data to make sure that data is neat for the next stage, which is featuring the data for, you know, prediction. So I think you will be needing this one in the program too. So this is SUV dot it's like case. We are trying to say this is also a pandas. Really, we don't need to write, because as far as pandas has been imported, whatever you be writing, this is also a pandas module. So whatever you be writing will just work just fine. So in this, we are saying this data, we want to write to the machine that we want this data, we want you to print if there is any null in this data. If there is any null in this data, as in if there is any row that has a 0 or has no figures there, it can, you know, it can spoil, you can just see a lot of error when you get to, you know, prediction. So we have to remove them. So click on that. You can see false, 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 meaning, well, I don't want to conclude. So now you see that there is no null. We now want to sum this up. We want to see if it's, because we cannot keep checking over 400 rows. It's not simple like that. It's not as simple as that. So we want to sum this up to see if there are really no null values in the dataset. So we can see we have summed it up. This is showing there is no null values. So we move to the next part. We just want to make sure that we are really sure. So we want to plot a heat map showing to to check how accurate this null. This is really not necessary. If you have seen this too and they're okay, you cannot do this, but just want to make it more colorful. So see, there is no heat anywhere, so it's just this neat, meaning we are good to go. So this is the training and testing. Now we have, this is where the machine learning comes in. This is where the machine learning comes in. Now why I put a hatch here is just like that, what do they call this, a markup. So just to make sure that it doesn't show, that's why I put, like, it doesn't like become something that you can run. That's what I mean. So now you're seeing a red, meaning it really doesn't show anything yet. There's nothing in front, there's nothing at the back, so it's like a markup or markdown. I think it's markdown. So now I want to separate this data into training and testing data. Like I said in the group, train is what will train the model using. That is, training data is what will train the model using. And test data is what we will use to check the accuracy of the model. So next we are going to look at, this is just you can do this in several ways. What you just need to do is to separate the x from the y. Now y is what you are predicting, or you are trying to run a predictive model on, and x is the predictive value. This is what, that is, this whatever is in x is what you will regress on y, which is the direct value which we want to predict. I hope this is explanatory. Whatever you want to separate x, like why you want to separate x and y is because you want to use x to predict y, but you're using a model which is more accurate. You can't even predict it without using a model. So now this iLog, you can it really doesn't necessarily mean you do this. You can map it, you can, but just for the sake of this simplicity, I'm just going to go straight. So just click X. Now we are trying to tell the system, hey, I want X, I want this X to be whatever is I think this is before 2 and 3. So we'll run this out and then we'll check it. Sorry, this is actually very good for the learning about the intro of Python. This is actually an intro. I just don't know. I think this is just what do you call it, a code to specify this to that you want to extract. You want the value to be used to run this. Y also will be y equals to SUV prediction. Please, I want only this value to be predicted. I want this value to be used as a direct value or dependent value. You know, in your undergrad, this is what actually they use, independent and dependent value. So this is dependent, this is independent. So let's run let's run this. So it has been separated, and then we'll check. You see, all this 1 0 1 0 means this 0 is that there was no car purchased. The ones means there are purchases, car purchases, car purchases, car purchases. That is SUV purchases. So 4, like now in the data, I don't know if, see the 1 2 3 4, the fourth. Now I didn't pick this because it's not really, it's just an ID to, you know, separate each customers or each consumers of this SUVs. So we really don't need them for predictions. We just need the gender, the age, and so on. So 1 2 3, I think it was only 2 I took. This is age, and this is estimated salary. Okay, I didn't pick the gender either. Sorry, this is a very old project, so please, just trying to remember what I did. Anyway, now that we are in this, so these are purchases. So 0 means there were no purchases, 1 means there were purchases. So let's go to the next step. Now this is scikit-learn, sklearn. This is another thing we need to import. This is very, very powerful, as you get majority of the predictive models from this scikit-learn. You get logistic regression, you get SVM modeling, you get k-means clustering, or k-means, yes, Bayes, linear regression, trees, that's forest, random forest, isolation forest, that's PCA, and the rest of them. This is where you get it from. So this is very, very important. This is where this is the machine learning itself. So you click on it to import it. Then from it, you also get pre-processing tools from this. We also get this is a, I think this is pre-processing. Okay, this is model selection too. There's a lot of things you can get from scikit-learn. So I'm just going to, now this is saying from this scikit-learn, in the category of model selection, import train test split. Train test split is used to split the data into test and train. That is exactly what I wrote the first time. Training data is what the system will have to run on. That is, the model will have to use to understand the data, and then the test will be used to, you know, test the accuracy of its understanding. So we are going to import train test split to split this data. Sorry, I don't talk this much, that's why I'm cracking. Anyway, now that we have splitted the data, now this formula is very, very important. It's actually, this is the whole train test split, as As much as I've been running on projects, this is majorly, although there are other ways to split a data set. However, I really love this place because it's more explicit, and you can be able to explain it when you are doing it. So now what we are trying to do is we want to split this data, as I said before. So we want to split this, we are telling the machine now, split this data into x test, which is x, which is this x that we have taken away. This x, we want to split it into x test and x train, meaning I want you to separate x test, I want you to separate x test and x train, and I want you to do the same for y test and y train. Don't know. Then I want you to separate these things, these two data, using train test split. I said using means equal to. Now I want you to separate what? This is the x and y I'm saying that they should separate, which is this that we have already separated here. We want to further separate it, and we want to separate it with the test size of 25, and then with a random rate state. So we want it to be separated. This one is not really necessary, but it's just to keep it on a static separation. Like, you don't, when you run the data again, you don't have to, it will not reshuffle, you get. So it will just be on a random state. That is just one exactly. So I don't know if I explained this very well, but I think that's so now that we have said that we want the test data, that's the test, to just be 25% of the whole data, the machine will understand that the remaining 75% is train. So we run it, and now it works out. Now we want to pre-process this data. Pre-processing is trying to make sure that the data is well understood by the model and will not bring back an error. It's just for it to be, you to understand the data, to be more understood by the model. We understand the data because we are higher creatures. We have to make it easier for the model to understand. So we are going to be using standard scalar. Standard scalar, if you had mathematics in your undergraduate studies, you understand what standard scalar is. It's for you to scale the model. It's trying to scale it to make sure that one is not too big than the other, or else there will be outliers, there will be wrong prediction, because one will be very much represented than the other. So I don't know if I'm explaining it very much. So it's just for you to break down the data to be more equal, but they will still retain their value, but it's just that it will just break it down to be more equal. So let me run this. So I don't want to be using standard scalar every time I'm running this code. So I want to name that standard scalar SC. So I click on that. So that's what that means. So now x train equals to xc. Now I want to fit this model. I want to fit the x train. Now that we want to work with x train, I want to fit the x train to be, because it's the x that we are actually trying to use to predict the y. So now I want to use this x train. I want scalar to scale this down to make sure that everything fits. So I'll be using the standard scalar. I'll be telling the machine I want the x train that I have already separated from the x test. to be scaled down by using fit transform to X train. This is like me. This is like this is naming the data. So I'm still naming the data X train because I don't want too much complexity. So this is what I just said now. This is it. So I run this, and then I do the same for X test. So now I know that they have been fitted. Don't know if I can run this separately. Let me try. So you see, now they have been scaled down. This is X train. This was what it formerly was. Now everything is equal. You get now what I'm saying? Everything has been matched. So there will not be there will not be any outlier, there will not be any bias predictions. So everything will be normal now. We go to, wow, I don't know how I've taken this much time. Now that we have run this to, now from scikit-learn, now we want to bring in the logistic regression. I said that this scikit-learn is very important. So from scikit-learn, in the categories of linear model, please import logistic regression. Now it has imported. We just told the machine what to do and it just did that. Now we are going to be making this regression, logistic regression. We want it to be called classifier. We don't want to be using logistic regression all the time. So we now say, machine, please call logistic regression at a random state of 0 classifier. And that's what it did. Now we want to fit the X train and Y train. Now this is where the prediction comes in. We want to use this classifier to predict, which is the classifier is the logistic regression. We want to use it to fit the X and Y train model. So that has been done at a random state of 0. Now I want to just ready your mind. This is very, very basic. All of this, it's very basic. For you to make sure that a model runs very perfectly with little errors, you have to do it with hyperparameters. And hyperparameters is something that you have to use a cross validation technique or a grid search CV. That's just to, you have to run that with it's like a pipeline. You have to run it on a code that will make sure that the hyperparameter that is chosen will be chosen by some algorithms to make sure that the code runs very perfectly and have less or little errors. That is something for another day, but this is just the basic. I just went straight. This random state, this is one, it's just one of the many hyperparameters. There's a lot of it to make sure that the data runs more excellently. So that's about it. So now that we have fitted the data, we want to predict the data. We want to predict X test. Now, what we have predicted here, we will use it to predict X test. I don't know if I'm communicating. So we'll be calling it wipe rates because it's more like a general name because that's yeah. So we are going to be using this class now that this classifier has fitted this this data has played its part. So now we want to use whatever this data has fitted. This one has the model has fitted like what the model have learned to predict X test using wipe rates, calling it wipe rates. That's Y prediction. Now that we have done that, from scikit-learn metrics, we want to import accuracy score. Now, there are several ways to check the accuracy of a model. This is just one. There's one they call classification report, which will show this and more. I'm talking, when I say more, I mean F1 score, recall, precision, that's, and then we have matrix score too. So, but for just this one, let's just keep it with the as simple as it is. So click on this. Now that we have imported it, we want to see how accurate our model is. Now we are trying to check the accuracy. Now we have tested it on this already. We have used it to predict this. We want to use what we have used to predict this to predict, Y test, and also sorry, I just made a mistake. We want to check the accuracy score, of Y test, and in percentage of 100, I think. So you click on it. So this is our accuracy rate. So there is a tendency that whatever will come out of this score will be 80.6% correct. This is moderate because when the thing is too high, which when you are using decision tree, that's where you see something of accuracy of 90%, 99%, in fact 1.08%. Honestly speaking, I've seen that before. So when you see those kind of percentage, you'll be like, that is a kind of high risk because you may just learn this data and this data alone. You may not be able to replicate it on other data sets. So, and that is very, very wrong. You may just predict just this data and that's all. You can't use it to predict something else. You can't use it to run another data set. So, meaning if you want to predict another data set, instead of it to just go straight to the point, by using the model that you have already built, you have to run all of this from beginning, all of this again and again and again. So thank you so very much. I hope this sorry for my mistakes. I may have said some one or two wrong things, but I hope this helps in clearing the doubts of or easing the tension. And this video is so long, but I wanted you guys to understand the communication aspect of it, what we are trying to tell the machine to do. So thank you very much, and if there are any questions in what I have just given to you guys can say something. I can recap, or I just write down the updates or whatever it is on the group. So thank you so much.